problem, we have a small object. It's got mass m and charge q and initial speed of 5 times 10 to the 3 meters per second. It's projected into an electric field where it deflects downwards and hits a wall down right here. We're going to try and find the charge to mass ratio. What is q divided by m? So let's think about what happens in this problem. I'll just add another sketch here. So we have our two plates right here, plate 1 and plate 2. Our charge comes in right here while it's in this field and experiences a downward force, so it will deflect downwards a certain amount. Comes out of this field, it says we're going to ignore gravity, so then it's going to start to travel straight until it gets over here and it hits this wall. So that's what happens. Let's fill in the things that we know. The distance from here to here, the amount it deflects downwards while it's in the field, let's call that y1. The amount it deflects downwards between when it leaves the field and hits the wall, let's call that y2. And that total distance, let's call that d. So what we see here is y1 plus y2 equals d. We would like to find the charge to mass ratio. The distance it travels depends on the velocity. The velocity it has depends on the forces. The forces depend on the charge and the mass. So let's write down some equations about the distance it travels. As we do that, we'll see that we'll be able to figure out our charge to mass ratio, q over m. So let's start with the first thing we said, which is that y1 plus y2 equals that total distance d. Okay, let's sort out y1, then we'll sort out y2. We'll put them in here and we'll put in our d, which we know is 1.25 centimeters. So for y1, we'll use a kinematics equation. y1 equals v initial 1 y component, and it has an initial velocity when it leaves here that's horizontal. V initial 1 y times the time in this path, t1, so from here to here, that's path 1. Plus 1/2 times a1 times t1 squared. So there's a kinematics formula. It's coming down, it's got projectile motion, so let's fill in what we know. Right off the bat, v01y is equal to 0 because initially it's moving horizontally. So that whole term is gone. a1 is the y component of the acceleration when it's between the two plates. So let's find what a1. Well, we know force is mass times acceleration. The force on the object is the electric force. The electric field points down, so the electric force is going to point down. So our electric force is minus q times the electric field. That's the mass times the acceleration. So our acceleration a1 is minus q times e over m. If we want to right here, we can put in some numbers. We know that our electric field is 800 newtons per coulomb. So we have minus q over m times 800. Now t1, let's find that guy. Let's ask, how are we going to find t1? Well, it travels a distance equal to the length of the plates. That's 26 centimeters. And the x component of velocity is going to be constant. So what we know is that x1 equals v01x, which is the whole thing, v01, times t1. So then t1 is x1, 0.26 meters, divided by v0, which was 5 times 10 to the 3 meters per second. So our time spent in between the plates here is equal to 5.2 times 10 to the minus 5 seconds. Okay, so let's put in this for our acceleration, let's put in this for our time, let's get an expression for our y1, which ultimately we'll plug in over here. So that's 1/2 times minus q over m times 800 times 5.2 times 10 to the minus 5 squared. Run that through the calculator, we get 1.0816 times 10 to the minus 6 times q over m. We don't know q and m, so we'll leave those as symbols for right now. Okay, so there's an expression we have. So next let's find y2. Why don't we do that in a separate video?